Hello everyone and welcome back to the Cyber Guru. In this video, we're diving deeper into the world of ethical hacking and reconnaissance. I'll be showing you how to use some powerful tools inside Parrot Security OS, including Sherlock for username hunting, Email Tracker Pro for email analysis, and Recon-ng for advanced reconnaissance and reporting. We'll start with the basics, explore different commands, and then move step by step into real-world practicals, from gathering information to generating a professional HTML report of our findings. If you're learning cybersecurity, penetration testing, or simply want to understand how reconnaissance works in the hacking lifecycle, this video will give you clear, practical knowledge you can apply right away. So grab your notes, follow along, and let's get started. Google has a set of advanced search operators that make your searches much more powerful. The site operator restricts results to a specific domain. Next, all in URL ensures all the words you type appear in the web address, while in URL looks for just one specific word in the URL. Then we have in text, which searches for words inside the body of a page. With all in title, every search term must appear in the title, while in title checks for just one word in the page title. There are also operators that focus on links. In Anchor finds pages linked with certain words, while all in Anchor makes sure all of your terms appear in those link texts. Some operators give you extra tools. Cache shows Google's saved version of a page. Link reveals which sites are linking to a page. Related helps you discover websites similar to one you already know. Info gives quick details about any page. And finally, location narrows results to a specific place. Let me show you some examples of how these operators work. If I type site bbc.com cybersecurity into Google, it will only show results about cybersecurity, but restricted to the BBC website. This way, instead of searching the whole internet, I can dig directly into a specific domain and quickly find what I need. Now, let's try another one. If I type all in URL careers space engineering, Google will bring up pages where both the words careers and engineering appear in the web address itself. This is really useful when you want to find specific sections of websites. One powerful trick is that you can also combine operators to make your searches even more precise. For example, if I type site developer.mozilla.org in text web storage, Google will first restrict results to the Mozilla developer website and then look for pages where the phrase web storage appears in the body text. By combining operators like this, you can dig deeper and filter down to exactly the kind of information you need. Now I want to show you a resource that power users and researchers turn to, the Google Hacking Database, or GHDB. The GHDB is a curated collection of search queries, often called Dorks, that target specific types of information exposed on the web, like configuration files, login pages, or accidentally published data. People use it to find things that ordinary searchers miss because the queries are built to look in URLs, titles, page text, and more. A quick warning, GHDB is a tool for discovery and defensive research. Use it responsibly and only on systems you're authorized to test. Next, I'll demonstrate a GHDB query so you can see how they find specific exposed pages and data. Now let's look at the Google Hacking Database, or GHDB, and how security professionals use it responsibly. I'll search for the GHDB and open the main site. On the GHDB, you'll find categorized search queries, often called Dorks. grouped by the type of information they expose, like configuration files, login pages, or device interfaces. For demonstration, I'll run a sample query from the GHDB to show you how a query is structured and what kind of results it returns. Now let's search for network camera. Here we can see the results. I will copy the second one and paste it on Google search. Here you can see live cameras. We'll go on the first one and see a live network camera. Important, when you test GHDB queries, do it only against systems you own or are explicitly authorized to test. Never attempt to access or interact with devices or data that belong to others. Use these queries to find exposures on your own infrastructure and to prioritize fixes. Next, we'll look at NetCraft, a long-running internet research and brand protection service that tracks hosting, infrastructure, and phishing activity across the web. NetCraft provides web-scale data and tools that help security teams spot spoofed sites, hosting changes, and other external threats. When you open a NetCraft site report, you'll see a compact summary, background information, how long the site has been seen, hosting, company and country, IP addresses and name server data, all the signals defenders use to verify ownership and spot anomalies. I'll show these panels on screen so you can see where the useful details live. Now let's open NetCraft and look at a site report. From the Resources menu, I'll go to Tools and click Site Report. A new window opens with the Site Report tool where we can enter a domain. For this demo, I'll use Amazon.com. Once the report loads, you'll see the background section, site title, first seen date, hosting company, and related metadata. Next is the network area and then SSL/TLS. After that, certificate signals such as certificate transparency entries. In the network tab, I'll click the domain link to expand domain information. That panel also lists discovered subdomains for the site, which you can review as part of reconnaissance and verification. If a cookie consent pop-up appears, just accept cookies so the page displays fully. Here you can see multiple subdomains displayed, each representing a different service or environment under the main domain. For example, companies often separate things like APIs, media servers, or regional platforms into their own subdomains. As defenders, this view is useful for mapping the attack surface and ensuring every exposed endpoint is properly secured. Now I am going to perform a practical demonstration of Sherlock in Parrot OS. Sherlock is a powerful open source intelligence tool that helps us find usernames across multiple platforms. You'll see how quickly it searches through dozens of social media platforms and websites, giving us valuable insights for reconnaissance and OSINT investigations. So let's jump right in and start exploring Sherlock on Parrot OS. First, we'll launch our Parrot OS terminal and run Sherlock with the H command. This displays the help menu, where we can see that a username is required as an argument, along with some useful options. Next, I'll use Donald Trump as the username, and here are the results Sherlock has gathered across multiple platforms. Now, let's make the output more useful by applying the output option. I'll store the results in a file named donald.txt. Once the scan is complete, let's open the file and take a look at the results inside. As you can see, all the findings are neatly saved for later analysis. Now let's open Mozilla Firefox and go to whois.domaintools.com. Once the page loads, we can search for any website. For this example, I'll use wikipedia.org. Sometimes it may ask for verification, and after completing that, the results page will open. Here we can see detailed domain information, including the registrar, registrar status, registration dates, name servers, IP address, IP location, ASN, and overall domain status. This data is extremely valuable in OSINT and cybersecurity investigations, as it helps us understand the background and technical details of any domain. NSLOOKUP is a built-in network utility used to query DNS records of a domain. It helps us find details like IP addresses, mail server records, and canonical names. In cybersecurity and troubleshooting, NSLOOKUP is very useful for investigating domains and verifying DNS configurations. Let's open the terminal and enter the command NSLOOKUP. A responsive screen will open where we can type the domain we want to search. For this demo, I'll type Microsoft.com. The result shows a non-authoritative answer, which means the information is coming from a cached source, not directly from the authoritative DNS server. To dig deeper, we'll set the query type to CNAME, which stands for canonical name. A CNAME record maps an alias name to the true or primary domain name, helping us see redirections and linked domains. Now, after setting the type to CA name and entering Microsoft.com again, we get the authoritative answer directly from the DNS, showing us the verified domain records. The next is TRACERT, also called TRACERT in Linux, is a network diagnostic tool that shows the path your data takes to reach a destination. It lists all the routers or hops between your computer and the target server, along with the time taken at each step. This is very useful for identifying network delays, routing issues, or pinpointing where a connection slows down. Now, let's see a demo. Open the command prompt in Windows as an administrator and type TRACERT/?. This will display the help menu and all available options for the TRACERT command. Here you'll notice the H option, which defines the maximum number of hops a packet can take before reaching the destination. Hops represent the routers or devices your request passes through on its way to the target. For example, let's try TRACERT h5microsoft.com. This limits the trace to a maximum of 5 hops. Now let's try TRACERT h30microsoft.com. This allows the trace to go through up to 30 hops, giving us a complete path to the destination server. By comparing these results, you can clearly see how the hop limit. Now let's take a look at Email Tracker Pro. This is a Windows-based tool designed to trace the origin of an email by analyzing its headers. When you load an email header into the program, it automatically extracts the sender's IP address, shows the geographical location, and even highlights if any part of the header has been forged or manipulated. One of its key strengths is automation. Instead of manually reading long and confusing headers, Email Tracker Pro simplifies the process and presents the information in an easy to understand way. It can also integrate with traceroute tools to give a visual map of the email's path. However, keep in mind that the accuracy depends on how reliable the header information is. Some results may be incomplete or show a rough location instead of an exact one. Also, it only runs on Windows and it isn't completely free. Still, Email Tracker Pro is a very useful tool for investigating spam, phishing, or fraudulent emails, and it can save a lot of time during an investigation. Now, let's open Email Tracker Pro. If you'd like to download it, I'll provide the link in the description below. First, let's go to My Trace Reports, where you can view previously generated reports. Next, click on Trace Header to analyze a new email header. To get a header, I'll open one of my emails click on the three dots in the top right corner and then select Show Original. This will display the raw email header. Now I'll copy this entire header, paste it into the Trace header window inside Email Tracker Pro, and then click Trace. The tool will now process the header, extract useful information like the sender's IP address, location and routing details, and present a clear report for analysis. Now let's move to Recon-ng. Recon-ng is a powerful Python-based OSINT framework designed to automate web reconnaissance. It uses a Metasploit-style command line and a modular architecture. Each module performs a specific task, like subdomain discovery, WHOIS lookups, breach checks, or scraping public profiles. The main advantages are automation and repeatability. You can run the same workflow across multiple targets and export clean reports in CSV, HTML, or JSON for analysis. On the downside, some modules require API keys, and module reliability depends on the external services they query, so you'll need to keep Recon-ng updated and maintain any required keys. In short, Recon-ng speeds up structured recon, centralizes results, and is ideal when you want reproducible OSINT workflows and professional reports. In the Parrot security machine, let's start by opening a terminal window. We'll execute sudo su to run the programs as a root user. Next, I'll run the cd command to jump to the root directory and then launch the application by typing Recon-ng. Now let's set up the framework by running marketplace install all. This will install all the modules available in Recon-ng. You can ignore the errors. Once installation is complete, type modules search to display a list of all available modules. From here, you'll notice modules that allow you to perform tasks like reconnaissance, exploitation, importing, and network discovery by loading the required module. Next, type workspaces to view the commands related to workspaces. To create a new workspace, enter workspaces create test. This creates a workspace named test. If we now type workspaces list, we'll see all the workspaces in the database, including the one we just created. Finally, let's add a domain we want to investigate. To do this, issue the command db insert domains and provide the domain name. This sets up our target for reconnaissance and allows us to begin using modules on that domain. Under the domain text prompt, type Amazon and press enter. When it asks for notes, text, type learning option and press enter. This adds the domain to the current workspace. Next, let's look for brute force host discovery modules. Run modules load brute to list brute related modules. For this demo, we'll use recon choch domains hosts choch brute hosts. So load it with modules load recon choch domains hosts choch brute hosts. Now just run the module by typing run. Watch the output. Recon-ng will begin harvesting host names by trying common host names and patterns. After it finishes, you can verify new entries by running show hosts. You should see hosts added from the brute main hosts. You can repeat with other modules like NetCraft or Bing to expand results. When you're ready, type back to return to the test attributes prompt. Now we'll perform reverse lookups for each collected IP to resolve them into host names. First, search for reverse lookup modules with modules load reverse resolve. For this task, we'll use recon hosts reverse resolve. So load it with modules load recon hosts reverse resolve. Run the module with run. This will query DNS for each IP collected and try to resolve PTR records to host names. When it completes, run show hosts again. You'll see the updated host list with resolved names. Type back to return to the main prompt. Finally, let's export a report of everything we harvested. Search reporting modules with modules load reporting, and for an HTML report load, modules load reporting HTML. After loading the module, configure any options required, output file name, workspace, and run the module to generate your HTML report. This produces a clean report containing all hosts and findings you can share or archive for later analysis. Here I will set file name to home/cyberguru/desktop/results.html, creator to cyberguru, and customer to Amazon. Now type run and press enter to execute the reporting module. Recon-ng will create an HTML report containing all the hosts we harvested. When it completes, the file results.html will be saved on the desktop. To open it, go to the desktop, right-click results.html, choose Open With, and select Firefox ESR web browser. The generated report will appear in Firefox and show a summary of all harvested hosts and findings. Expand the hosts node to view every host that was collected. You can click each entry to inspect details, IPs, and any associated metadata. This report gives you a clean, shareable view of your reconnaissance results. If you learned something new, drop a comment below and tell me which tool you want a deep dive on. Also, next video, I'll teach reconnaissance using AI. Share this with a friend who's learning cybersecurity, and don't forget to hit the subscribe button.